test 11B, we'll start with the multiple choice. So first of all, on this first problem, it says they want to know if there's a leader amongst the 5 most popular manufacturers for laptops or whether they're equally popular. So we're going to set up the null as that they're equally popular. And then this is a chi-square goodness of fit. So we're not going to be talking about independence or the distribution being the same between the two groups because there isn't two groups. So chi-square goodness of fit, null hypothesis for chi-square goodness of fit is everything as it's supposed to be. And in this case, it would be that they're all equally popular. So that would be choice C, that the people in the population are equally identified the 5 brands as most trustworthy. Okay, number 2, the following conditions must be met in order to do this hypothesis using a chi-square test. Each respondent is randomly selected from a population. Okay, I don't know how you're not selecting that one. It's got to be 1 for sure, right? It's always got to be done random. All expected counts are at least 5. That's correct for chi-squared, not for the other variables, I mean the other units, but for chi-squared it is. And then the population is normally distributed or n is large enough for the central limit theorem to apply. That would be the large counts condition for a means problem, which is great and all, but this isn't a means problem. So 1 and 2 only. Okay, and then the next one is what about gives the test statistic for Toshiba? So I have the formula card here, and right down here on the front at the very, very bottom, we have this equation. It gets kind of messy, but it's observed minus expected squared divided by expected. So when I look at this with these answer choices, these are the only 2 that fit the mold that I'm looking for. That I don't even know what that is. I mean, I guess that's missing the squared. Like maybe we could make that up. This one has a big square root around it, so that's not something that we need either. And then between these 2, we have to decide, well, which number goes on the bottom? Is it the expected or the observed? It's the expected, right there from the formula. I mean, that is a straight formula card question. If you know where the formula is on the formula card, you essentially cannot miss that one. Can't miss that one. All right, next. This one, the next 3 questions are all going to be using from this one right here. So is there a difference between male and female toddlers? And then they went through and they did it based on which color of toy they picked up first. So does the color of the toy picked up depend between male and female is pretty much what they're asking. Also, notice that it is multiple samples. So that means it's not chi-square test of independence. Chi-square test of independence needs to be 1 sample. They did a sample of boys or males and a sample of females and then ran the test off of 2 separate samples. So that's homogeneity. The null hypothesis for homogeneity is that the 2 groups are distributed the same. All right? So that's choice C. Let's see here. Okay, and then see how they do the associated, an independent. Okay, so that would be correct if independent, E would have been the correct answer if it would have been a chi-square test of independence, but it wasn't. This one was a chi-square test of homogeneity. All right, the next one is cover count. No, it's not. I'm sorry. This one's the expected value. So it wants the expected value for a male that will choose blue, which is this number. We had 34 observed, but what's the expected count? And you do the column total, 58, times the row total, 116, divided by the total, 236. Okay? And on this one, they didn't even make us come up with the answer. It's just one of these maths is right, and which math is it? And it's this last one. If you divide by 236, you only have 3 choices, but then the only one that's using the the column total times the row total at the top is choice C. I'm sorry, that's choice E. All right, the next one, if they give us chi-squared. Now, first of all, we could run chi-squared test with this whole thing and plug in everything. But on this one, they gave us the chi-squared variable. And so if I go to second vars, and number 8 is chi-squared CDF. Inside that maybe looks a little bit clearer right there. So I hit enter. Now the lower value is always the chi-squared variable. The upper is going to be something ridiculously large, and degrees of freedom is cover count. Now let's see if I can actually, there we go. They've actually covered it. Nope, there we go. And then, so I've got 3 spots left. So my degrees of freedom is 3. And there's my 4%, which is in between 2.5% and 5% right there. But just real quick, if I look at the chi-squared distribution, it looks like this. It's skewed right, all right? So on this one, that's why when we count out 8 and we chop it off, p-value is going to be the area of the tail. Because this data or this distribution is skewed right, the tail is always going to be on the right. So you're always going to put the low value, 8.134, until infinity, or something ridiculously large like 100 or 10, or not 10, but 100 or 1,000 or something like that. But there's a little more explanation, and besides just there's what you plug the buttons on the calculator. All right, the next one. Now, the next one, I got some predetermined stuff, or pre-filled in stuff, including I got in the totals columns. They didn't give us the totals columns, which is going to be very important for question 8. But anyway, for the first one, degrees of freedom, cover count. Boy, when I look from my point of view, it looks like it's covered, but on the camera, it's not. So there you go. I covered the Studebaker, I covered the body cosmetic, and there are 8 remaining cells, so degrees of freedom is 8. All right, good. All right, now these are the individual chi-squared statistic values, the individual ones. So I'm going to go over this real fast. So on right here for the Hudsons needing brakes repair, we had 5 observed, and then 6.07 is the chi-squared value for just that piece. And what we would do is, from the formula card, let me go ahead and grab that. It's observed minus expected squared. So we had 5 observed minus the expected amount squared divided by the expected, and that was what was equal to 6.07. That's what these numbers over here represent in this table. It's very confusing what the heck they're even talking about. Because we don't make y'all do this by hand. Maybe we should, but we're not going to, and we're not, anyway. So anyway, the bigger the number is, the further apart the expected was from the observed. The smaller the number is, like that one was almost exactly the same, probably off by 1 or 2. So essentially we got exactly what we observed, and then everything in between. So this one was a high one, 7, that's a big one, that's a big one. Those were all large. And then the actual, like when we say chi-squared equals 8.37, that's what you get when you add up all these, which of course it would be much bigger than maybe even 28.37. But if I add up all these component values, that gives me my chi-squared answer. All right, then the question is tricky because it says which of the following is true, meaning that we have 5 true and false questions. And then we have to go through and pick out the one. So the answer is D, and we'll come back to that, but let's go why these other ones aren't correct. So the chi-squared test statistic is less than 10. Well, that one is 6, that one's 7, almost 8. Actually, when you if you add up the decimals, we get 14 for those 2, plus you got all the rest of them. It ain't less than 10, right? That is definitely no way. The greatest difference between observed and expected is electrical repairs for Packards. So here's Packards electrical. That was the one I pointed out that was almost exactly the same. As a matter of fact, that's the smallest difference, or at least within the ratio of, let's just leave it at that. Okay, the greatest number of observed Hudsons requiring brake repairs is much higher than we would expect if the null hypothesis was true. So the number of Hudsons that required brake repair, so up here, Hudson brake repair, that's this 5. So what I need to do is I need to find its expected value. And again, I've already got to go ahead and put in these totals. You can grind them away if you want, but and be careful. Like I added my numbers incorrectly when I was doing that. That was kind of irritating, but I did this one and this one here double check to 199. So I'm feeling very good about that one now. Anyway, like I said, just misadded these. It was pretty dumb, but But yet it happens to everybody, right? So we do 50 times 57 divided by 199, and you can type that in your calculator if you like, but I'm telling you it's 14.3. This one says the number of observed 5 was higher than the expected. No, the expected was like 3 times higher. So that one's not correct. Although, again, I might get tricked into picking that one because the number was large, but it's actually smaller. So you can tell if it's far away with these numbers. You can't tell whether or not it's bigger or smaller. And then the observed counts of Packards requiring body or cosmetic repairs is close to the expected amount. So Packards requiring body cosmetics. So Packards, body cosmetics, 0.2. I don't even need to find the expected count for that one. That's correct. If that number would have been big, it would not have been correct, but that one's pretty good size. And then this last one says Hudson's with train repair. So Hudson's train repair is about the same as the Studebaker is requiring. Okay, I guess I wasn't. So this one, they're actually not too far apart. So the expected counts you get for Hudson's with repair train, with drivetrain repair is 11.17. The Studebaker's is 17.6. That one's kind of tricky. But D is definitely correct. E would be the best wrong answer if that does anything for you. But of course, in a multiple choice, there is no second place. You filled in the correct bubble and you get credit, or you don't, and it's a no-go. Anyway, all right, and then this number 9. Ooh, this one's rough. I got lucky, and I don't know why, but for some reason I looked at D first. Don't ask me how. And that one's correct, and I'll at least explain to you why D is correct. So this goes back to understanding that chi-squared is right skewed. Okay? And whatever I get from my chi-squared value, I chop off the graph, and that tail is my p-value. So this p-value would be pretty small because that tail's pretty thin down there, and I got this big old wad of values up here. So I don't know, maybe this p-value would be 5% or 4%. Now, what this one says is if the probability that chi-squared is greater than c plus 2 is less than 0.05. Oh, I'm sorry. It does. Right here it says the probability that chi-squared is greater than c is 0.05. So that means this shaded region right here is 0.05. I'm kind of all over the place, but we'll recover here and get this taken care of. Now, if I take C plus 2, so this is the location C. All right, so that's where chi-squared is, it's at C. If I did C plus 2, and I don't know exactly where plus 2 is, but I'll just say it's there, what do we know about this tail? Not much. I do know, however, that it's less than 5 because that's not nothing, and the whole thing is 5, so this piece right here is less than 5. Right? And I tell you, some of these other ones, I don't know. I wouldn't worry about it too much. I don't believe I picked one of these like this on the test, our actual test. This is the textbooks test, and I like their test, but over the course of time, I've just found questions that just aren't on exams, and I'm not spending time doing stuff that's not on the exam. That's silly. All right, and then here's the multiple choice, number 10. And again, this is one where we see, and sometimes if you want, you can glance at the answer choices, and we can kind of work from that. So we're either going to reject null, accept null. No, we're not doing that. That's other schools that will pick that one, not independents. All right, and then reject null, fine. Failed to reject. All right, well, I was able to at least get rid of B. All right, now, when do we reject and when do we fail to reject? It's all about p-value versus alpha. My p-value is greater than alpha. If p-value is greater than alpha, I failed to reject. So now I have a 50-50. Okay, and then if we fail to reject, it's because we don't have evidence for the alternate. And that's one of the reasons why we make you guys write that conclusion down all the time. I mean, look how much easier this question is if you know what the conclusion is. All right, I think I'm going to do a separate video for the FRQ questions and the multiple choice. So that's the end of the first video.